Okay, let us begin with problem of mechanical translation system. How we determine this problem is a mechanical translation problem mean the given problem has mass m1, m2, k1, b or b1 like this. So this problem had been received or had been f of t x m1 m2 b k like this features are having mean this problem is a mechanical translation problem. We have to conclude this problem at the end of transfer function. Okay, so we justified this problem is a mechanical translation problem. We have two differential equation in this problem depends upon the given mass m1 and m2 given mass. We have two differential equation. Among these two differential equation going to be solved the transfer function of x of s by f of s. So beginning this problem we have to conclude what are the input and what are the output given in this problem. Here one input and two outputs are there. One input is f of t, two outputs are x and x1. So those three features has to be take Laplace transformation. So f of t Laplace is f of s, x of t, x of s, x1 of t, x1 of s. From these are input and output, we can derive transfer function is output by input. So here two outputs are there, but we take final output x. So x of s by f of s. This is conclusion of the entire problem. Let us start the problem from m1 mass. We have two masses m1 and m2 masses. Start from m1 masses like node 1. We can draw separately m1 mass having these all are forces. So individual force fm1. So attached forces are fb1, fk1, fb, fk like this. There is no input. Here x1 is output. So we make by Newton's second law. There is no input means 0. So equal adding of total forces fm1 plus fb1 plus fb plus fk1 plus fk. Here we know about this mass formula, viscosity formula and spring formula. Equally we are replacing each and every formula of here. Just notify this x1 minus x comes from this b viscosity. It is connected in between of m1 and m2. So which is most preference goes to x1 because m1 we are seeing. So representation of m1 we takes x1 is first minus another output of mass. Based upon that concept here friction or viscosity or velocity having b into d by dt x1 minus x. Same like k are connected in between of m1 and m2. So m1 having x1 displacement, m2 having x. So going to give most preference to m1 mass. Why mean we are seeing m1 mass. So k into x1 minus x equal to 0. This is differential equation. This equation called differential equation. This differential equation on taking Laplace transformation. Okay, when we will take Laplace transformation, the equation is m1 s square x1 of s plus b1 s into x1 of s like this equation. This equation going to be short out the output of m1 mass. So output is x1 of s. We can segregate x1 of s of common things, x of s common things in this equation. both part separate and equate of them, and finally we can rearrange x1 of s into x of s bs plus k by m1 s square plus b1 plus b into s plus k1 plus k. This is equation 1. This equation comes from m1 mass. So like this wise we can solve at node m2 here. M2 having input f, output x, then all the connected forces of here. So input f of t equal to connected force, adding of connected forces. So each and every forces having some formula, mechanical translation formula, you just apply. After applied this formula, we can taking Laplace transformation for that differential equation. So that Laplace transformation are shown here. Then we can come out the common thing of point. In this equation, f of s is input, output is x of s. We want x of s because this is going to be derived transfer function. So we just come out this x of s from all those things given here. X1 of s is adding one moment of here. Already x1 of s values as like first equation, that x1 of s equation going to be substitute here. After substituting, we can conclude transfer function of x of s by f of s. The values just put it down here. Hope all are understand this concept. Next class we will see.